Hello friends, Namaskar. This is Rahul. Today I will be going through my AI lab job match analyzer. So the agenda of this is to go over this AI lab, understand what is the what is the problem statement that we are trying to resolve, how it is done, and show a demo. So let's start with the demo first. So this is my AI portfolio assistant. So let's go to the job match. uh, what it does, it has a resume already feeded, my resume feeded into the application, and we can choose the JD. So let's choose the JD that we want to compare against to check the overall match percentage of my resume skills against the JD skills, and run it. In meantime it is running, let's go over to the overview what it is. The problem statement that we are trying to resolve is how I find my how I find the right jobs that matches with my skills, and it also helps to the recruiters to find out the right talent and making ensure that the candidates are evaluated fairly based on their relevant experiences or relevant expertise. It has 5 capabilities. First, it reads my LinkedIn profile and resume and extract the explicit skills mentioned using the LLMs and convert it to embeddings. The second, it reads my job descriptions. It reads the job descriptions and extract the skills using LLM, do some pre-processing like making it case insensitive, deduplicating and ranking the top 10 skills, and create the embeddings. Then we use the machine learning models pipeline to find out the strong matches, weak matches using encoders like by encoder, find and cross encoders. And if we still have lower percentage, then we use Gemini LLM to find the relevance and compute the at the last we compute the overall match percentage and provide the score. So let's go back, and here is the result. We see that the JD and my resume matches 70%. It shows the match skills like Java, Spring Boot, React, and some of the missing skills, and it provides the reason that why it is missing. Mostly I have the experience in microservice architecture, but I may not have mentioned it explicitly. So that's what it is trying to say, that maybe the overall it is there, but it is not mentioned explicitly. You can download this and share if required. So it will have a PDF, and same information is created into the PDF format. So let's deep dive into the code. So it has a 3-step. First, it pre-processes the skills, removes the duplications, remove the unnecessary, unrequired information, then use LLM to get and extract the skills into the list, comma separated, and ranked based on the job description. And then we use the machine learning pipeline to do the skill matching. So we create the embeddings for the job descriptions, skills, and the resume skills. We find the cosine similarity, and if it is still not okay, then we use the LLM to get the relevant score. So let's go to the code. So this is the code. It uses the Python APIs, fast APIs. So the endpoint that we are looking at is API match. So as we see, we have uploaded the job description, so it will read the PDF file, it will extract the job description. So for extracting the job description, it will first clean the text. So utilities are into the util.py file. Okay, and then this is the prompt that you are an expert in analyzing job descriptions, and you extract the skills only explicitly mentioned, do not infer. So it extract the skills, and then we again normalize and clean the skills and create the embeddings. And similarly we create the embeddings for the candidate skills, and we use that for cosine similarity. Now let's go back to what is embeddings means. So embeddings is nothing but creating a numerical format for your strings. Okay. The best analogy is, let's say we are comparing two cities, Now we create embeddings based on some coordinates for the cities like the population intensity, distance to IT hubs, average income. So say for example, we have three cities, we create three vectors. So Pune has some vector, Pimpri has some, and Mumbai has some. So when we compare two cities, we find we do not like compare Pune and Pimpri Chinchwad, but we compare their embeddings. So as we see, the coordinates of Pune and Pimpri are almost same. So if we are comparing two cities, like I live in Pune or I live in Pimpri Chinchwad, it will provide me a cosine similarity of 98%, whereas if I compare it with Mumbai, that I stay in Mumbai or I stay in Pune, it will provide me a cosine similarity of 45%. So that's how the cosine similarity works. So it works similarly for the resumes. So if I have say a resume skill mentioned React and job description skills is mentioning React.js, the embeddings for those vectors will be nearly same. So if I am comparing React against the React.js, it will provide me a strong match. Whereas if I am trying to compare React against say for example Java, it will provide me a lower match, right? So it uses the embeddings for strong match. So it will get the coincide and it will try to find out the strong matches. If I have more than 10 strong matches, then I consider it as a very strong match between resume and JD. But if I have lesser strong matches, then I go to the second fallback method, that is cross encoder. Cross encoder is nothing but LLM model, machine learning model that is used for comparing the sentences having partially or fuzzy matches. So say for example, I have something like skills like AWS mentioned in my resume, but the job description mentions Amazon Web Services. So it will compare those texts because it knows, the encoders knows that AWS is the short form of Amazon Web Services, right? So it it does the weak partial match skill matching, and how it that's how it gets the value for the overall matches. uh, so we will just go through that, and if still the percentage of after cross encoder match percentage is less than 50%, then we lastly fall back on our LLM. So the prompt is like, you are an expert in comparing job description skills and the resume skills, and I feed some skills to it and ask him to provide me the JSON, valid JSON format in some JSON format mentioned here. Okay, and it provides it. So after we get all these three, we put it in the dictionary. So if I have all three fallbacks are used, I will have a dictionary where I will have matches, and then I will calculate the maximum match out of it, and based on the maximum match I will get the reasoning and use that reasoning to show on our screens. So if I go back to our portfolio, the reasoning is calculated based on the base match, and it will check the missing skills and provide us how my skills are matching. So based on your extensive profile, your expertise in microservice is exceptionally strong, covering strategic leadership and blah blah. Okay, so that's the overall the technical stack that I use for this lab. Is I have built the backend APIs using the Python's fast API. The embeddings, I have used the sentence transformer and cross encoder models. The Gemini Gemini LLM is used for AI for production, and for local environment for testing purposes I have used my own Olama LLM. So I use the Llama 3.2 model for that to make sure that the application is uh, good enough for production. And the UI is built in the React using React.js and the Tailwind CSS. uh, that's all. Thank you very much for watching this, and if you have any questions, please put it in the comment. I will try to respond.